Hey everyone, welcome to the third and final episode of the Dutch Android summer season. My name is Rob. For those who haven't seen, we're getting started with Ben Weiss from Google. Welcome, Ben. It's great to have you. How are you doing? If you can
I'm all
hear
right.
me.
Thank you so much
Yeah,
for having me, Rob. Yes, I can hear you. And as we tested earlier with the different headphones, it worked fine. I hope that you can hear me as well.
loud and clear. Yeah, great to have you.
Perfect. Yeah, I'm very happy to be back at the Dutch Android user group. I remember a couple of years ago, I was at the Dev Fest in the Netherlands, and I very much enjoyed this. Huge fan of the cycling infrastructure that you have in the Netherlands. And we've been cycling last year over here and enjoyed it so much. We wanted to come back this year. It's not happening, but it's still on the plan for as soon as we can go again.
Yeah, it's great to have you again. It's been too long, and you're always welcome to come visit. So definitely anytime.
Thank you.
So you're working at Google and you work you work on Android developer relations. And I heard you also you coordinate the Android GDE platform or the GDE
Yes.
program. Can you maybe tell us
Yes.
a little bit about that?
Well, the Android GDE is essentially a badge for people in the community that are very active and share their knowledge with the community. There is somebody, well, not going to take away all the things here, but we have Hugo coming on up later, who also is an Android GDE. We also have in the Netherlands, there's also Wiebe living there, also a long-time Android GDE. It's basically folks in the community that have been sharing a lot of knowledge with the community, and we give them the recognition that they deserve with this. And it's a program that we've been growing over the past couple of years. I was an Android GDE before I joined Google, and I still have a lot of love for this community. So that's why I grow it inside of Google and help to share the love for that and the connections inside and outside of Google with us.
Nice. Yeah, we as a Dutch Android user group love the whole GDE program because it gives us lots of great speaker. We actually had Wiebe on last time, so it's great to have him. And of course, Hugo will be back today. So it's really good stuff. All right, so today you'll be talking about modern Android development. Yeah, if there's nothing left that you want to ask us as a Dutch Android user group, I think we're ready to just dive in and see what questions pop up. And I'll come back at the end of the stream so we can highlight all these questions and see if you can answer them, hopefully.
Yeah, let's hope so. Yeah, please line up the questions. Very happy to talk about modern Android development, and it's awesome that you're having me here.
Nice. Well, with that, I'll leave the stream for now and see you after the talk. Good luck.
All right, thank you.
Thanks.
So, hello everyone. Like we just said, I'm Ben. I want to talk to you about modern Android development today. Modern Android development is, well, modern. So before we go into the modern part, let's talk a little bit about how we came here with a little look about what was with classic Android development. And the best way to cover what happened in the classic times or in the older times is to take a little stroll down history lane. So let's go down and see where we came from and what brought us to where we are at the moment. We had the first release of the Android SDK with the Milestones 3 SDK in late 2007, which brought in Java programming language as the main language for Android development. The first level of platform APIs, a lot of tools for the Eclipse Android Developer Toolkit, and APKs as the distribution mechanism. Then over time, we had more platform APIs. We had 1.0 as the first release in late 2008. Then over years, more and more platform APIs. In 2013 at Google I/O, we announced Android Studio as a new IDE to use, and in 2017 we were supporting Kotlin as the first level language, as the first language as well for a second language for Android development. And in late 2017 at the Android Dev Summit, we introduced the architecture components as a new way to develop Android apps, which is basically a lot more things that came from the support libraries and the things that we learned there. And at I/O last year, we introduced Android app bundles as the new distribution mechanism and made them publicly available for everybody to use as well. That is kind of where we came from, where we are. So from the Milestones 3 SDK, with a lot of steps in between, we came to what we now would call modern Android development. So let's go through a couple of the classic bits in more detail. So let's start with the first part, which is the language. Classic language, we chose the Java programming language as the Android developer language in the first place, mainly because there's already been a large developer base. So a lot of people were used to develop to the language, and it is the tooling around it was free. So people could use it. Everybody that wanted to learn Java programming language was able to learn it, and they could just use the language as it is. And compilers were free. There's libraries out there. There's patterns. There's best practices. A lot of material out there to learn with it. Also, there is very good memory management on this, comparing it especially to native languages like C++, where you have very robust memory management. That means you don't have to allocate, deallocate, but basically that gets taken care mostly for you with this. Let's take a look at the next pillar, which is the tools. Tools, we chose Eclipse, and we integrated the Android Developer Toolkit into this. And we made it available for free as well for developers to use, and so developers could use a familiar developer experience that they already had for free. And it integrated the new tools, subtools into the IDE with Eclipse. And well, I mentioned this before, but yeah, it's free. So developers could use this freely, and people could start learning developer platforms there, and could just, from university students, already could start with this without actually having to wait for companies to buy into this. But everybody that had access to a computer could start using can use the tools there. The next big thing that we want to talk about is APIs. The APIs, we had regular releases and bug fixes and new releases, but it took a long time to get the features that were brought into with the new releases, and also the bug fixes and the new functionality down to users. But we had all those platform releases, and we had new releases frequently. In the beginning, really, really frequent releases that then slowed down to a more manageable pace. And now we have new functionality in every release, like I just said, and a lot of bug fixes in these releases. So let's take a short look at a little bit of timeline here as well. In 2008, late 2008, we released Android 1.0, and then in 2009 we had a lot of releases up to 2.0, and then slowed down a little bit to biannual releases, with 2.2, 2.3 in 2010, and then slowing down to an annual pace, which is the pace that we're currently keeping. And with this pace and this cadence, it's developers still can keep up with all this, but we're, as you see, like this is where we're currently at with the stable releases that we have out there. But like I said, this takes time for developers to pick them up. Also, on the other hand, the APIs that we had in the classic world essentially means that everything that comes out new takes a while for users to pick up, takes a while for developers to pick up, and we saw a lot of problems that came up with this. I know that we already know solutions that we brought out since then, but I still wanted to highlight this is where we came from. And another big thing is distribution. That's the fourth big pillar that we saw in classic Android development that we also bring into modern Android development. Distribution has been done through APKs. APKs is essentially a zip file of all the code and resources that you have for your application that you ship to the user and then get shipped to the user. If you wanted to have more configurations, so say configurations for different screen sizes or for different CPU architectures or for different languages or the likes, that would mean you either had to have more APKs that you would have to manage yourself with multi-APKs. If you've ever done that, you know how much time that can take into account. Or on the other hand, to make it easier for you as a developer, you had just bigger APKs. That brought its own classic problems with it. Speaking of classic problems, let's take a look at a lot of different classic problems that all those four main categories and main pillars had. We just talked a little bit about the basics that we had. So with these basics, there is all these, well, classic issues and problems that we had. With the language, the Java programming language is an awesome language, but it's verbose. With tooling, we had Eclipse and the Android Developer Toolkit. It was difficult to customize for our teams. It was really hard to integrate a consistent UI consistent UI in the tools that we had there. And the core IDE hasn't been actively improved especially for Android, and we weren't able to influence that, and we didn't have a lot of control in the way that we wanted to work and improve the IDE there, rather than just working on the Android Developer Toolkit. For the APIs, we had the platform, and developers were massively limited by getting the new releases out to the users there as well. And it was difficult to adapt new technologies and bug fixes into these releases because the users still were on old releases. And also it was fairly complicated. If you ever looked at the way that you manage lifecycle, storage on the device, or navigating between different activities or fragments, well, that used to be fairly complicated. For the fourth pillar, for APKs, we had monolithic APKs that could handle all the different possibilities for your users' devices. As you know, like there's a lot of different devices out there that you can that a user can use, and all of these devices that are out there mean essentially that you can handle a lot of different ways, but the APKs weren't designed for this in the first place. So you either had a monolithic APK or you had a lot of APKs with fairly complicated processes that you had to work with. As I highlighted in the beginning, we've come a long way, and we found a way to call this. And we call this, with our answer, modern Android development. And what is modern Android development? It is development tools, APIs, language, distribution technologies recommended by us, the Android team, to help developers to be productive and create better apps that work across billions of devices. That sounds very flashy, but let's take a look at what I mean with this. It's essentially kind of under the roof of modern Android development. We have 4 pillars, which is language, tools, APIs, and distribution mechanism, based on the foundation, which is a platform, and the Google Play Store on the other hand. So let's take a look at what we mean with modern. Modern language would mean Kotlin. Kotlin is the programming language that we've seen developers use a lot, and that we chose to say this is the programming language that we recommend developers use in the ongoing. Let's take a little bit of a look at the timeline, a very short history there. In 2016, Kotlin version 1.0 came out. We know that there have been Android developers using it before and recommending it before, and it took us a little while to evaluate things there. And at Google I/O in 2017, we officially said, now is the time to start adopting Kotlin for Android, and we support the language on Android as a developer language. At Google I/O in 2019, then we said we're going Kotlin first. So that means we're not just saying that developers should be writing their applications in Kotlin, but we also write our own libraries in Kotlin where it makes sense. So for example, with paging 3, we added coroutine support for Room, WorkManager. Also things like Jetpack Compose and the likes is written with Kotlin in mind. For navigation, for example, we also have a specific Kotlin DSL. It's already out there. We added more trainings, examples, documentation, all in Kotlin. And our documentation has parity between the 2 programming languages for Android as well. And 2020, if we take a look at this, we now have coroutines preferred. And now it recently had a release of Jetpack Compose Alpha as well. So this is where we are at the moment. Why did we choose Kotlin? It is an expressive language. Expressiveness means that we really have to write less boilerplate code. And well, that's really a good thing because writing less code means you make less mistakes. And also it gives you type safety. Type safety means that you have nullability at the language level as well. So that means that you can't accidentally have a null pointer exception because you know if something is null or not. Also, interoperability is a very big factor for Kotlin because that means that you can seamlessly interop between Java and Kotlin, and you get structured concurrency. So you can write elegant asynchronous code, and you have to easily avoid spaghetti callbacks. So let's take a little bit at the code that we can write with Kotlin. This is just a very quick activity with a on-click listener we set in there. And it demonstrates a lot of things that you can do with Kotlin already. So you have nullability built in the type system. So the bundle could be null, that's shown by the question mark. You have lambdas, which make it easier to write succinct and readable callbacks code in this case. You have extension functions. In this case, you can have on a string function, on string, you have a capitalized function, which is not baked into string itself, but is an extension function on top of that. You also have template expressions, so that means you can make string concatenation a lot easier to read and write. Also, it's compile time safe, which is fairly helpful because that makes it harder for you to have exceptions at runtime there. And you have one of the really cool things as well is the property access syntax. So that means that you can, instead of having to type a set background tint list, you can just use the equals annotation. And so that means that you set and get your call the getters and setters underneath just by writing the equals or just having the access on the property through the property access syntax. that's a couple of things that makes it really, really easy to read and write and a lot more succinct than with Java programming language. Another thing why we chose Kotlin is speed. Well, what do I mean by that? It's speed of development of the language. The runtime library gets developed very, very quickly. Also, Kotlin coroutines was experimental, for example, last year. It's now fully supported. Flow is working on there as well. And extension methods that we can work on that as well. That makes it a lot easier for us to quickly iterate over things that are going on and keep up with that on for the developers as the community evolves there as well. Also, we've seen a lot of uptake. Developers seem to like it. So 60%, more than 60% of professional Android developers use Kotlin in their applications. It's more than 70% of the top 1,000 Android apps use Kotlin in their apps, and more than 60% of Google's applications are written using Kotlin code as well. Within Google, we work a lot with Kotlin, so we have several initiatives where we work to improve Kotlin support and tooling, so both for Android as well as we bring back a lot of things to Kotlin as a language itself through the foundation that we built with JetBrains. For tooling, we have lint checks that we created. We have a dedicated compiler team which works on R8 optimization, on annotation processing speed. If you take a look at the symbol processing, comparing that to KAPT, for example, that's one of the things that we're doing. Also, we work on the annotating platform APIs. So that means that we added recently nullable and recently non-null to platform APIs. So that means that recently those nullability annotations have been added. And in the first iteration of a platform release, this will give you a warning. And in the next release version of that, so if we add a new recently nullable for 30, for example, for 31, that would mean that, well, this will be nullable and non-null. At this point, you will get a compile error. So you have one platform release to make changes and fixes there. And those are one of the things that we make sure that we add those annotations over time and are not breaking immediately, but give you time to adopt on this. Another thing that we do is we have Kotlin extension libraries. So a lot of the libraries that are in the Android X libraries have Kotlin extension libraries annotated by the -ktx notation. And they give you improved platform APIs outside of the platform releases. So what do we mean by that? So there's two things. One of them is the platform APIs that we improved with the KTX, and another one is where we improve on already existing APIs. If we take a look at the platform APIs, let's take a look at the bitmap API. If you ever wanted to create a bitmap and copy that, if you ever create a bitmap and, if you wanted to create a bitmap copy of a drawable object, then, well, you first need the bitmap creation API. So you create a bitmap and pass it in width, height, and a bitmap configuration. Then you draw that on a canvas, and then you have to write within your app all this code where you have the boundaries, where you then set the bounds, then you create your bitmap, then you draw it on canvas, and then you set the bounds there. There's a lot of things that can go wrong with this. So let's take a look at how we managed to encapsulate all of this for you. We created a function on drawable, which is the drawable KT extension. And there's a function that's called toBitmap. So you can take any drawable and pass it into a bitmap, and it will give you a bitmap directly. So basically you pass in the intrinsic width and height, which is already there for you, and then you pass in a configuration which could be null. So within the application, all you have to write is drawable to bitmap with a width and height, and there you go. So instead of 6 or 7 lines of code, you have 1 line of code that you have to write, and it makes a lot less error prone and a lot harder for you to make any mistakes there, and a lot easier to iterate over things that you want to draw on your screen. It's just one of the things that we've been doing, so you can find all those on GitHub. You can improve on them as well. You can contribute to them, and you can also easily use them and make your development life a lot easier with this. Another thing that we're doing is we create Kotlin-specific APIs. For example, for Room and WorkManager, for paging 3, we're working on APIs that are specific to Kotlin and make sure that they work very well with Kotlin. Paging 3 has been completely rewritten for Kotlin and in Kotlin, including coroutine support from the get-go. In WorkManager, we have coroutine support baked in that makes asynchronous code a lot easier to write. And we do have Compose, which is our new UI toolkit for Android, written completely in Kotlin with Kotlin developers in mind. We also do things for documentations, samples, and training. For our documentation, we make sure that all the new documentation that comes out is written with Kotlin in mind and Kotlin first as well. Same as for our samples, they're written in Kotlin first, and our code labs are written in Kotlin. We created courses, we created articles and videos, for example, the Kotlin vocabulary series, and we continue iterating over this. And basically, Kotlin is part of one of the key pillars of modern Android development, and that's what we're currently doing, and we're ever expanding on this. So let's go on to the second pillar, which is modern tooling. Modern tools means you use Android Studio for your development IDE, which is built on top of IntelliJ with the great code that you can write with the heuristics in there, great refactoring tools, and it's got all these capabilities that IntelliJ brings, and which also has a lot of things that we brought in with the Android capabilities there as well. Let's take a brief look back at how that came in. In 2013, we introduced at Google I/O Android Studio. I sat in the audience there, and I nudged a colleague while I sat there, and I said, "Told you so. This is going to happen. This is really good. This is going to make our life so much easier." And oh my, I was right. I'm so happy about this change. That was made things so much better in there for us as Android developers. And in 2016, late 2016, we then deprecated the Android, the ADT, so the Android Developer Toolkit for Eclipse, said we're not going to develop on this any further, and we're focusing all our efforts from the Android developer teams that work on the tools on Android Studio support, so make sure that we're actually going forward with one streamlined way in this direction. This allowed us to introduce things like the constraint layout editor directly in the IDE that we weren't able to build outside of Android Studio within the tools that we had available with Eclipse, but now with the Android Studio IDE, we were able to build this. Also things like support for Kotlin that we got built in with IntelliJ in the first place, we could improve on this as well. We had possibilities to add CPU and memory and network profilers in Android Studio 3.0. In 3.1, we added D8 as the default compiler for DEX code. And 3.2, we added energy systrace profilers. 3.3, we added a navigation editor, which is one of the key things that we use for navigating and making navigation of your app a lot easier. And there's view binding in there, there's a motion editor, and there's currently compose support as well as one of the latest things that we've been building that was enabled and powered all through Android Studio there as well. So with modern tools, we also had powerful code refactoring through Android Studio, so you easily can refactor code and pull it out through a couple of shortcuts and key shortcuts that makes it a lot easier to do your things there. Also, migrating to Kotlin, for example, is a lot easier through Android Studio there as well. We have a extensible UI that we can build for future tools. As you've seen, there's already a lot of things that we've been doing, a lot of things that are going on at the moment, a lot of things that we can be doing in the future to make all of those integrated and seamless within the IDE for you as developers, so you don't really have to leave it because everything's built in where you want it to have it, where you're spending most of your time during the day. Also, the core plugins are being developed actively by both JetBrains and Google, and we work together very closely with the teams at JetBrains to make sure that the development goes on there, and that we also integrate, for example, tightly with Kotlin and Gradle to make sure that these things work very well for Android as well. Also, be able to add things like lint checks and quick fixes directly into the IDE, so that way you can see, oh, there's something that I shouldn't be doing, and we can easily give you a quick fix for this with a lint check that runs automatically for you in the background. But most importantly, it allows us to integrate with new and existing APIs that come out. So for example, navigation, layouts, data binding, room for coroutines as well, or things like Jetpack Compose allows us to integrate all these things in a way that you can, as developers, easily have everything baked out of one solid piece. Make sure that we can make sure that this makes it as easy for you to develop Android apps as we can. That is the second key pillar for modern Android development, which is tools. So let's take a look at the third key pillar, which is modern APIs. Modern APIs is essentially Jetpack. Well, Jetpack is a lot, which is right now somewhere between 80 and 90 libraries that are out there, going through a lot of different stages from developer snapshots to alphas to betas to stable releases. So we're not going to cover everything. So we're just going to cover a part of Android Jetpack. And in the tradition of this presentation, let's just go through a little bit of a history lesson here. Firstly, in 2017, we launched Constraint Layout with a 1.0. That's a lot of new powerful APIs, and that made the layout process a lot easier for you as developers. With late 2017, we also launched Architecture Components 1.0, which contained lifecycles, view model, room. And at I/O in 2018, we launched Jetpack, which was the key rebranding for the then existing support library. A lot of things came in there as well. We added paging as a new library in alpha then, navigation as the new way to navigate your application between activities, between fragments, And we added WorkManager as a new way to do deferrable work in the background. Also later that year, we added the material design components under the Jetpack umbrella. And the last year at Google I/O, we added Jetpack Compose as a new announcement, as a developer snapshot, and Camera X is one of the key libraries that we've been writing there as well. There's a lot of things that happened in between there, so this is just a highlight of a couple of things that we think that I think is important to talk about today. And also this year, we introduced the motion layout, the motion editor, to make animations and motion across your apps a lot easier for you to write those, because we knew in the past this has been a bit of a pain point. So this way we gave you new IDs, new APIs with the tooling hand in hand out of one way that you could use both of that in the same way. And currently we do have the Compose alpha, which we definitely want you to start playing around with and taking a look at this before we can go into beta at some point with this. So all the feedback that you have now is really, really helpful for us to make sure that in the future things get for you in a way that, well, you want it to be. So with this brief history lesson, let's take a look at, again, where we're coming from. Well, if you take a look at the lifecycle diagram for an activity, I have, in my years as an Android developer, stared at this long and hard and thought about if it was possible to make this easier and better than having to overwrite all these functions and not caring for these anymore. Turns out it is possible. You use the app compat activity nowadays, or the app compat fragment. They're lifecycle owners. With the lifecycles architecture component, what we can do is you can declare an observer, and you can add an observer to that, in this case, in your onCreate method. And the observer that you have is essentially an extension of the lifecycle observer. And you can say, through either an annotation or through a check of the lifecycle state, you can basically run your code at a specific state, and you always get informed when something happens once this observer is registered. This makes your life so much easier, and it makes it so much harder to leak context and to leak lifecycle states there. Another thing that we did is, well, if you take a look at live data, which is one of the libraries that we offer as well for you, and on the other hand, if you take a look at view model, which integrate quite nicely. So let's take a look at, we have our user interface, and on the other hand, we have our data side, which has a view model, and that view model holds several live data. Then you can register your user interface to the view model and can observe changes on the data there. And once something changes, you get notified that there has been a change. So this way you can now have a reactive approach that it wasn't possible in the first place. But now this is possible through the libraries that we provide there as well. Also, this doesn't just stop here with view model and live data. Underneath that, we have the Room DAO that makes it possible to integrate into SQLite. And with Room, what you can do is you don't have to write your SQLite code anymore by hand, and make sure that it, well, compiles, because there wasn't compile time checks back in the day. But now you get annotations for this as well, and for queries that are compile time checked. So we make sure that you don't have any runtime exceptions on this anymore. And you make sure that this now completes for you immediately. You have possibilities to have either queries, which you can define, or you have the insert, update, delete directly built in, so you can have all your functions easily without having to make any changes on the SQLite code yourself. But you get all this through compile time checks there. And in between that, you can also have paging. So that means if you have a very large list of data that comes from your database, you can have this through page object. So that means that you don't have to manage everything in memory at the same time, but you can request new pages as they come along. This is just one, well, fairly big example how our libraries can work together. We can even plunge in more for this. So we can have things in the background for example, kind of have WorkManager in there as well, which Hugo will talk later on today. So that's one of the things that you can be using here. And even more on top of that, the coroutines could be in there as well, which is highly likely to have that at some point. So as you see, all of these libraries, they work together quite well, and even better in the future as we continue developing on top of these. One of the really cool things here as well is that all of this is backwards compatible. So this doesn't mean that you only can go forward looking, but you also can use these backwards compatible down to, well, API level 14 for much of it, but some of those, not newer API levels, but much of it is down to API level 14. Like I just said, the libraries are built to work together. View model and live data are lifecycle aware, so that makes it hard for you to leak context, and updating data is only, for example, for inactive UI elements is really impossible with this. Room can be accessed via view model and the live data object, so that makes it easier for you to separate your data layer from your UI layer. You have coroutines and flow in Room that you can use directly baked in there as well. This makes it easy for database access to be off the UI thread, so it makes it harder for you to have any issues there and to have lag and jank in your application's UI. And also RX friendly. You can also use RX Java. There's no example of RX Java in here, but yeah, you can just trust me that works as well, because that's one of the things that we're looking at there as well. Another key thing that we had is that we looked at is navigating your application. Navigation is, well, it is an interesting topic, and it has been debated a lot within the Android developer community. And we saw that it is inconsistently done, at least. So we decided whenever you create a new activity with a basic activity, we give you possibility to create this with the navigation component baked in. So that makes it easier for you to navigate your application. So this is what you get when you start a basic activity. You get a navigation graph. That navigation graph navigates between two fragments. And underneath that graph, which is the part of the IDE in here, you have the possibility to also edit all of this using XML, or on the other hand, you can use the Kotlin DSL to write your own code to navigate between different activities or fragments, or like whatever you want to write on top of this as well. What does this take away? The cool thing is that you don't have to write and care for the fragment manager anymore. You don't have to care for which of those you use anymore, because that's all been taken care of by the navigation component. Also, one of the key things that's been taken care of is the way that a backstack is being recreated and created. Same as for activities, that if you navigate between activities, then you can set your destinations easily, and the backstacks can be created for you, so that you don't have to do this part of the application development yourself, but you basically declare this once, either in your graph or in your XML or your Kotlin DSL, and then all you have to do is use the navigation controller and then navigate to a specific ID from a specific ID, and the navigation component knows exactly how to take you from one point to the next point and creates everything in between for you, so that you always have a consistent way that you can go back when the user goes back to a different state. Also, you have navigation agreements, the navargs library, so that allows you to pass data between different destinations, so you don't have to do this yourself anymore either, so you can use the navargs there as well. And with the fragment management, it's a lot easier. You can create single activity UIs a lot easier as well. Which gives you, like as I said, consistent up and back handling, and support for dynamic features is now available as well. So that means that you can also have feature modules that aren't installed at the first place, and the navigation component knows where to check for it, download it, and you can include all this in your navigation graph as well. Another big library that I wanted to talk about is WorkManager. WorkManager gives you possibility to execute deferrable work. Where timeliness is in many cases less important, so that doesn't mean that you have code that is being installed has to be run immediately. I'll just briefly cover this, because I know that will be covered in a presentation later on today as well. So let me just quickly go through it. Basically, it's guaranteed background work. It's persistent across the device and app restarts, and it allows you to run deferrable and guaranteed background work. It's not a replacement for things like Alarm Manager, but in many cases, it's the right way to use to run code in the background. It's compatible down to API level 14, and it gives you support for example, periodic tasks, chained or sequence tasks, and parallel tasks, and gives you possibility to define execution constraints. So, for example, connected to the internet or charging. So let's take a quick example for filtering a couple of images that filtering an image you've been taken. So let's assume you've just taken a photo and you want to run some filters on top of that. All of those three filters should be done sequentially. and they should only be done when the battery is not low, which is our constraint there. After that, in the chain, that should be compressed, but that should only happen if the storage on device isn't low, which is our second constraint. And then this all should be uploaded to well, your backend somewhere. And all of this only should happen if you're on an unmetered network. So how would you do that? You create a worker, extends a worker, which does work on, and once the worker is done, you basically return result success, so this all worked fine, or result failure if it didn't work fine. And then on top of that, you in your code define your constraints. So that would be, in this case, the requires battery isn't low, so that means that there is enough battery available. You add this constraint to the worker request on here, setting the constraints, and then you add the second filter and so on, and then you begin the 3 filters and queue that into your work queue. And afterwards you say, oh, that should then be compressed and then uploaded, and then everything is being queued and being run for you and executed until everything is successful. Another thing that you can do is you can run your code immediately with WorkManager if you set your code to be run in a foreground service. In order to do this, you pass in a notification, a foreground info, which calls on a notification, run this everything in the foreground. So that means that your code is being executed immediately as soon as the constraints are being met. And other than that, it's essentially the same. After that, you run your work, you do some work, and then you return result success or result failure. That was a very brief overview, because I know that a lot of things will be covered in a later presentation, like I just said. So let's move on to CameraX. CameraX is another of the libraries where that has been developed because we have heard that the developer community has had problems with taking photos, and how photos have been taken on Android has always been inconsistent through to a lot of different various reasons. So we created CameraX, which works on 95% of Android devices down to API level 21. It has consistent output across different devices, and it is a lot easier to use than the platform APIs that we had in the first place. And it is built around 3 main use cases. The first is preview, which essentially just means that gives you a viewfinder and shows you what's live in the camera feed, and you can take a photo. And the second is image analysis, that gives you access to more camera frames. So that means you get every frame, and you have the possibility on those bytes to run your algorithms against it. That enables you to write features like object detection or work with augmented reality to insert something into the images there. And the third one is capture, which essentially is just like fire and forget. Take a picture, save it to disk, and then return me some information on where to find the picture. Let's take a look at the capture use case, because that was one of the key use cases that many developers had in the first place. So in order to just capture a photo, what you have to do is you create and configure the image capture object. You give it a config object, and in the config you can specify the parameters, like resolution of the picture that you want to have. Then you build it. The challenge here is that users love Android for the device diversity, but as developers that can be difficult because, well, parameters, they work on one device, but maybe not another. CameraX handles this diversity for you, so you don't really have to care for whether that works or not, because if it doesn't work, CameraX defaults back to the next lower quality that it can give you automatically, so that you get something that is close to what you want. It might not be 100%, but it is closely enough so that it actually works for you. And that's a lot easier than having to figure it out on every single device. In the second step, then you bind all this to your lifecycle, and then you basically just take the picture in the first place. So that is very little code that you have to write, and that is a code that works on many, many devices. It doesn't work on all of them, but it works on most of the devices that are out there, and it makes taking pictures a lot easier for you than taking pictures without CameraX. So if you work on something that takes pictures, CameraX is the right way forward for you to use. So closing the API section, we're always doing new stuff. So there's a lot of new stuff that coming out for modern Android development APIs. We have been doing new releases very, very frequently. We have new releases, new APIs in development. For example, Jetpack Compose, Hill Paging 3 has been coming out. And there's more stuff down the pipeline as well. And those releases come very, very frequently. Recently, we added possibility for a couple of libraries that you can contribute directly through GitHub. So that makes the contribution process a lot easier for you as well. And there's more things that you will be seeing across the year and across next year as well coming. So that leads me to the fourth pillar, which I've been working on as well a lot of things there internally here, which is Android App Bundle. The Android App Bundle is a new way to distribute applications. It's not the part that is being installed on device, that is still APKs, but it's a new way to make the distribution of your app a lot easier for you. We introduced it at I/O in 2018. We said, oh, Android App Bundles is here. And one of the key things that we saw is why we decided to get this to you as developers is that about 30% of devices have less than 1 gigabyte of internal free space on their, so the users have less than 1 gigabyte of free space. And that means the users that are storage constrained are a lot more likely to uninstall an application that they're not using as much. So users without free storage are about twice as likely to uninstall compared to users with perceived free storage. And that also means that the install success rate goes down a lot more the higher the bigger your application is. Actually, to that point, we've seen if your app decreases by about 3 megabytes, then you have an increased installation success rate of about 1%. And 3 megabytes is, well, just a couple of images in a resolution that is, well, in many cases not being used by users because you have resolutions from LDPI to quadruple X HDPI, and even others that you might have to ship within your APK. With App Bundle, you don't have to do this. How does this work? So with a legacy APK, what you had is a single APK which installed everything on the user's device. So the LDPI, HDPI, XDPI, double X HDPI, everything. Also the native code that you would have in your app that would be shipped down to the user's device, even though they have one CPU architecture. That's never ever going to change. Also languages. Well, languages on device can change. Languages are, in many cases, those strings aren't the big factor, but still, the languages are fairly stable on a user's device. So instead of shipping everything, we thought, what about if we just take parts of that? If we just take the CPU architecture that's required, also just the disk density that the user has, and the languages that the user has, and just ship this to the user. And that's what we did and enabled with app bundles. So that is everything that you could get out of the box with an app bundle. The Play Store does all of this stuff smart for you, so everything gets shipped to the user that the user needs. Everything else they don't install, and we have seen a dramatic size savings depending on which side of what kind of app you have there. But on top of this, we also have Play Feature Delivery. Play Feature Delivery enables you to ship features to your users as you need it. So that means that you ship some users, for example, somebody has some devices don't have a camera. You ship the camera module only to devices that have a camera. Some devices might be VR ready, so you only ship the VR ready the devices that are VR ready, the VR modules, and you can distribute your application in that way. And you can also have features that are being installed on demand. So when the user meets a certain point in your devices, in your application's lifecycle. So, for example, if the user decides to buy a premium feature, after that you then ship the premium feature. You don't ship it in the first place when they install it, because they might never get there. But if they get there, you can install the premium feature, and you can even uninstall all your ads that you have, all the ad modules that you might have in your application. Same goes for example, for onboarding flows, which can be videos that take up a lot of user space. So you can have this installed in the first place and then uninstall it later on. A little bit of side information on app bundles. We have more than 500,000 applications on the Play Store in production with app bundles. We have more than 35% of active installations on the Play Store with app bundles as well, and nearly 50% of the top apps and games are using app bundles on a day-to-day basis with production applications. We've seen about 20% of size savings with app bundles, comparing it to monolithic APKs, which, well, just by that, not by making any more changes on top of this, if you optimize your application through feature modules even further, you can have more size savings. But even just by making a switch from, instead of saying, well, Gradle assemble release to bundle release, and shipping that through the Play Store, we give you this major file size savings already. Those are the 4 key pillars that we had for modern Android development, which is Kotlin as a language. We have Android Studio as the tooling solution. We have a lot of APIs through Jetpack and the Android X libraries. And for distribution, we have the Android app bundle as the four key pillars for a modern Android development. If you want to learn more about modern Android development, we have developerandroid.com /modern Android development. And I'm also available on Twitter and right here in just a moment. And with that, thank you very much. And looking forward to all the questions that you might have.
Thank you so much, Ben. Great talk. Really informative and a great history lesson as well. And to see how far Android has come, it's really cool.
Thank you very much for having me. That was a lot of fun.
Nice. Yeah, I remember sitting in university and downloading Eclipse, which was definitely free. I remember that as well. And playing with the Android tools there. Yeah, it really got me into Android and still loving it and all the tools. Yeah, it's been great.
Yeah, likewise. I was very happy to see back then that I could go into this, and it got me a lot closer to programming than, all the very abstract things that we did at university.
Yeah, that sounds super familiar. I just love playing around and building something that actually, I was able to install on my phone and see and play around with. It really got me into it. So, really helped. Shall we see if there's any questions? I think people are actually a bit shy. There was a small discussion on whether the XML preview was already in Eclipse. I think they concluded that it was at some point.
Yeah, I remember something being there, but it wasn't as closely resembling to what we could do now. So basically just maneuvering around the different layout parts and moving them, and something like the motion editor or constraint layout editor wouldn't have been possible with Eclipse.
All right. There's actually a question popping up by Stephen Mulder. Let's see. Question about app bundles. We see weird crashes where the app cannot find some NDK component. Is it fair to blame app bundles for this? Specifically, users downloading the wrong app bundle.
That is a very good question. So if users download the wrong app bundle, that usually means they don't get it through the Play Store, but through something else. And many developers have seen this kind of to be a good way that if their app is being pirated, that the users, if they only install the base module, that doesn't really work for them. If this is something that I can follow up with, very happy to do so. My DMs are open on Twitter. Also, if there's an issue, I'm happy to look at it on Stack Overflow or on GitHub on the samples that we have there. I wouldn't say this is generally app bundles, because we've seen app bundles work with a lot of games. We've seen it work with a lot of applications that use native code. So it's not a thing that we have like as a general issue with app bundles.
Clear. All right. So Steven, feel free to reach out. I think that's if you have any more questions, that's really nice that you're available for that kind of stuff.
Yes, please.
I don't see any question popping in yet, but I was also wondering something. So you mentioned that the Camera X works with nearly all of the devices.
Yeah.
Nearly. What does nearly mean there? What if you run into a device that doesn't work? Is there any way you can still? Yeah, what do you suggest doing then? Or should you just drop these devices and bad luck?
That's still one of those things where if we can't do it, then you might have to write your own code here, and you might have to write your own camera handling code. But still, if it works for more than 90% of the devices, that means for these 90% of devices, you don't have to do anything there. But like for this less than 10%, you would have to write your own code to handle the taking photos or running your own use cases on top of this.
Fair enough. There's always edge cases like that. I guess.
Yeah.
All right. Any more questions, people? Let's see. No, Stefan came back with cool, so he's happy.
Glad to hear
get that answer. But no, other than that, I think it was very clear. So props for that.
Thank you so much. I'll be hanging around on the chat a little bit, and I'm available on Twitter. Very happy to take questions on, like I said, Stack Overflow, also on Twitter or the Android Dev subreddit, or the samples that we have out there.
Awesome. Great to hear. Well, thank you again. And with that, we'll dive into a quick break and we'll be back in 10 or 15 minutes with Hugo. All right.
Awesome.
right, I think we're back. Audio is working and everything. Welcome, Hugo. Great to have you.
Thank you. Great to be
How are
here.
you doing?
I'm doing quite all right. Thank you.
Nice. So you've been working on the Corona Melder app, right? How's that going?
It has been a roller coaster. It's been an interesting project for sure.
Interesting in a good way, I hope.
Yeah, of course. It's a new technical challenge because it's all new technology, of course. It's also something that could be important in the fight against COVID-19. And yeah, it's a big project in the sense that there are a lot of people involved and a lot of things are happening. So and of course the political side of it as well. So it's a lot of things that make this interesting.
Yeah.
To me.
Sounds interesting. Yep. Also, to view from the sidelines a little bit, because everything is being open source and stuff, it's quite nice to see what's going on there a little bit. Exciting stuff.
Exactly. Yeah.
So is that also how you got onto working with the WorkManager, or is that just a side project?
No, WorkManager, I've worked with WorkManager before, but Corona Melder is using WorkManager, of course. And yeah, so I thought it would be interesting to talk about background work in general, and also a little bit about the options you have and how you debug it.
Yeah, sounds
because
good.
There was some debugging involved, I can tell you.
I hope so. All right, well, sounds great. With that, I'll just leave it to you, and I'll come back into the stream with some questions, hopefully. Right. Good luck.
Thank you. Okay, let's start. For those who don't really know me, I'm Hugo. I'm a long-term Android developer, independent developer at Little Robots, currently on Corona Melder, which is the Dutch COVID notification app. And I'm going to talk about some background work. And yeah, let's just start with some background. Just some context first, what I mean with background in this talk, at least. I think there are a couple of categories of background work. First one would be work that should happen after some delay or somewhere in the future. Example of that could be, for example, if you have a functionality in your app that shows a notification, and maybe you will want to give the user an option to snooze that notification for a time, then you could schedule some work to re-show that notification after some delay, like 5 minutes, 10 minutes, or whatever you want to snooze it for. That's one category. The other category would be work that doesn't necessarily need to complete immediately, but eventually. What I mean by that is, as an example, you could have an application where you have a profile picture of someone, you want to update your profile picture. You could just update that locally, fire off some background work, and eventually that would upload the picture to the server and do all kinds of other fancy stuff with your API. But to the user, it would look as if this happened immediately. And the background work would then take care of checking if there's internet connection. If there is, it would fire off immediately, and otherwise it will just wait and upload a profile picture. If something happens along the way, it might retry it, that kind of stuff. So it's something that would complete eventually in that sense. And the last category is what we are dealing with Corona Melder a lot. That is work that should happen once in a while or periodically. In the case of Corona Melder, we need to check some things on the server to be able to notify you if you were near someone who is diagnosed with corona. Yeah, so think of things like doing a daily job of things. For example, if you have an email app, you could think of deleting the items that are in the trash can every day or something like that. So to me, that are the three categories. What is not background work is something that would happen very frequently. So something every minute or every second even, or something that happens in your app while your app is in the foreground. That would typically not, I would not consider that background work in the sense for this talk. Yeah, there are other mechanisms for that. So what I want to talk about is the mechanisms that Android provides for doing background work. And there are basically three main ways to do this with Alarm Manager, Job Scheduler, and WorkManager. And Ben already touched upon WorkManager, so that's great. And then I want to touch upon the battery optimizations, because that really affects all these mechanisms a lot, and in particular those in app standby. And then I want to take a look at debugging this and maybe do a little bit of a demonstration on how you can debug it. Yeah, so let's dive into Alarm Manager. Alarm Manager is basically the original way to do some background work. It has been around forever, and it's a very simple API in the sense that it allows you to schedule a wake-up signal. A wake-up signal that tells your app to perform some task, and it offers exact timing in that sense. So you can tell Alarm Manager to send you that signal at 12 o'clock every day, for example. And this typically triggers a broadcast receiver, and that broadcast receiver, because it is a broadcast receiver, has about 10 seconds to do its job. If you have something that lasts longer, if you have a more intensive background task, then you have to figure out how to move from that broadcast receiver to a service, for example. And that would involve handling your own wake logs to prevent the device going to sleep while your work is running. We probably all have been there in the past. There were some support libraries for that. This is an example of how that would look. You get the Alarm Manager, and then you have your operation, which is a pending intent that will trigger a broadcast receiver. And then you tell the Alarm Manager, this is just one of the many flavors that are available. You would tell it to invoke that operation after some time. So in this case, we're using elapsed real time, and then we just add an hour to it. So in the next hour, this intent would be fired on the device. Well, Alarm Manager is pretty simple, but it also has a lot of problems here. For one, it doesn't manage any wake logs for longer running tasks. This can be error prone. If you're doing this wrong, then you might drain the battery of a user's device. If you're doing this wrong, you might just not be able to perform that work that you're trying to do. Also, alarms are not durable, so they are gone after your device is being rebooted, which is inconvenient, and at least means that you have to manage those alarms yourself somehow. And because potentially every app can set an alarm at every minute of the day, it's not very battery efficient. And as of KitKat, there have been restrictions in place to make sure that if there are multiple alarms, they get batched together so that they run at the same time and that kind of stuff. And there are more restrictions in later versions of Android. So that's Alarm Manager. In Android 5, their job scheduler was introduced, and that takes a little bit of a different approach to scheduling work. It's more of a central service to manage jobs, and so it looks at the entire device, basically. It throttles, it makes sure that not too many jobs are running, it makes sure that the device is not bogged down because of a lot of jobs being run. So it's really coordinated by the system, and it also does not provide any exact timing. So in Job Scheduler, you can't tell it to run a specific job at a specific time. It also applies quotas. So if you try to run a lot of jobs, then it will just throttle your app in this case. So there's much more control over how jobs are executed. There are also time limits on how long a job can run, for example. And what's nice about Job Scheduler is that it can leverage constraints and backup policies. So you can express in Job Scheduler that you want to run a job, for example, if the device is connected to a network, or only if the device is connected to a power source, or whenever a photo has been taken and has been put in the media store. And that's pretty cool. And the other cool thing is that jobs can have retry policies. So if a job fails, what do you do? Do you retry it? And if so, how do you retry it? can be exponential, can be linear. Yeah, so that's a great improvement over Alarm Manager already. And jobs can be durable. You can ask the system to persist those jobs so that if you reboot, that the jobs will be kept alive and will be restored, basically. I don't have a code sample because you should actually never use Job Scheduler. You should use WorkManager for this because the WorkManager is basically the preferred way for doing background work. Also because Job Scheduler turns out to be a little bit buggy, especially on Android 5, but also there are also various other bugs. And WorkManager provides a lot more stuff than Job Scheduler can provide. It does retain the same semantics, so it's still no exact jobs. So you can ask WorkManager to queue a piece of work and execute it immediately, and it might do it if it has, if it's possible. But it might also delay your job for a little bit, depending on the state of your device. It also retains the constraints and it implements those in a backward compatible way. So depending for Job Scheduler, you would be dependent on the version of Android, but with WorkManager, you can basically use the constraints across all versions of Android. Some constraints might be introduced in newer versions of Android, and WorkManager just abstracts that for you. And in WorkManager, Ben already mentioned this, jobs are durable, so they were restored on boot, on reboot, and they're also restored when, for example, a user would force stop your app. If you force stop an app, then all alarms and all jobs will get cleared from the system because, the user indicates that it doesn't want to use your app or does not want to have your app active. If the user changes his mind later and starts your app again, then the jobs will be restored and overdue jobs might be executed again. So it's a common API for Job Scheduler and Alarm Manager on the hood. On Android 6, it uses Job Scheduler, and on other versions, it uses Alarm Manager. And it works around a couple of bugs. And one of the bugs that I saw in WorkManager being workaround is on Android 6, apparently you have to enqueue 2 jobs on Job Scheduler to be able to run a single job, which is something that you would bang your head against the wall if you would find out this yourself. Another nice feature of WorkManager is that it doesn't only rely on Job Scheduler or Alarm Manager, it also has its own in-process scheduler, which means that it can execute a job in a more greedy way compared to the system if the constraints are met. So this enables that scenario where you just upload a profile picture. If all the constraints are met, if there is a network connection, then it will just basically work as if you fired off that execution in a background thread yourself, but it will still run with the same API, which is super nice. So what's also nice about WorkManager is that it has a better API than Job Scheduler. In Job Scheduler, you basically have to implement a service with some extras, with some more lifecycle stuff. In Job Scheduler, in WorkManager, you only have to implement a worker. And if you write in Kotlin, you want to write a coroutine worker. And coroutine worker does what it says. It runs the work that you want to perform in a coroutine. And within that coroutine, you perform that work and then you return a result. A result can be success, can be a failure, or can be a retry. And well, that's pretty straightforward. One thing to look out for that, especially if you have periodic jobs or jobs that have to recur, that you want to be defensive in how you handle whatever the work that you are doing. So how you have to make sure that you catch exceptions, for example. If you don't catch an exception, the worker will just fail with a failure and will really never be retried. So if there's a situation where either a failure means that you just give up without retrying, or you explicitly want to retry, then you have to make sure that you catch those exceptions as well. And the other thing to look out for is that still the limits for jobs apply here as well. So if your work takes too long, then your coroutine will be cancelled here. And also if the constraints change, then again, the coroutine will be cancelled. If you need longer work times, then WorkManager also supplies something for this, which is you can set it to a 4-count job, and that will run it in a 4-count service, and then you can show a notification, and it will run as long as it needs to be, and as long as it is allowed, of course, by the system. And that's all in the same API, so that's super nice. And then you can schedule that work, and there are multiple request builders for this, but there's basically one-time request builder, and there's a periodic request builder. If you want to fire off some work one time, then you use the one-time request builder. You can set some constraints on it. Most typical constraint is probably the network connectivity, because it doesn't make sense if you want to connect to a server if you don't have any connectivity. So this will only run it when there's actual connectivity. And then you can set, for example, an initial delay on it and build that request. And you can also specify those back-off criteria that are present on job schedule as well. And especially for network type operations, I would always recommend to do some retry either in your worker or let WorkManager that handle that, because even though you can set a network constraint, it might be that the network is not fully up depending on the device. So what happens sometimes is that the system says, hey, I've got network, but then you try to resolve a server name, for example, and DNS is apparently not working. If you then have that retry set, then the worker will automatically be retried, and then the next time it will probably work. And then last step is enqueuing that request. Pretty simple, just one single line. There are many more options here, but yeah, check out WorkManager for that stuff. So this might be super obvious by now, but what should you use for background work? Well, in most cases, you should be using WorkManager. It's super flexible and has a common API for all kinds of work that you want to do. And it has that in-app process scheduler, which is just very powerful. But there might be some cases where you still need Alarm Manager, and that's especially if you are writing something that is time sensitive. So if you're actually building an alarm clock, then you would need Alarm Manager. Or if you have something that needs to remind you or that kind of stuff. And also maybe if you have something that only requires a short wake up, then Alarm Manager might be more suitable, but I would still recommend to check out WorkManager first for that. Also keep in mind that Alarm Manager wake-ups usually, well, in a lot of cases, won't have access to network per se. So WorkManager setting a constraint is probably more reliable in that case. Okay, let's switch gears a little bit and talk about battery optimizations, because so far I sort of ignored this and made it sound like whatever you want is actually going to happen immediately on your device. However, that's no longer the case as of Android 6. So in Android 6, DOS was introduced, and App Standby. And App Standby is a feature where the system will determine if your app is deemed active or not. And depending on that state, it will impose more restrictions. In Android 9, they further improved this by having App Standby buckets. But first look at DOS. What is DOS? If your device is stationary on battery and the screen is off, I don't think the stationary is always necessary anymore by now, by the way. But in that case, the most typical example is probably when you have your phone on your nightstand and you're sleeping yourself. Well, then your phone is probably dozing as well. And what happens is that at some point, the phone will decide to basically ignore all wake logs, making a turning off of all network, and then basically not allowing the system to wake up unless necessary during that time. And then at particular points in time, it will shortly enable apps to do some work. It will that is called the maintenance window, and it will then allow some network. It will schedule some alarms, and yeah, that's basically the gist of those. But this greatly affects how your work is being scheduled and executed as well. So let's talk about app standby buckets then. App standby buckets, this is more the Android 9 and up version, but it's similar to the original intention. In app standby buckets, the system tries to understand how frequent you use particular apps. So there are 4 buckets here. There's active, working set, frequent, and rare. If your app is considered to be active, then there are pretty much no restrictions on your app. However, if you are ending up in that rare bucket, for example, an app that you might open once and then never use again, then there are more restrictions. We'll still be able to execute background jobs, but it will just not be as frequent as it would be in the active mode. Depending on your app, this might be a problem or this might be fine. How the system determines this is based on usage and magic, or also called machine learning. And it's not super defined how that works. It also depends on the device a little bit. Here I have a table from the Android developer site that outlines how those features are related. So if you look at the those section, you see that both jobs and alarms and network are being deferred to the next window, the next maintenance window. And even for push notifications, those are deferred until that next moment the phone is awake for a brief moment. You see that for alarms there is an exception there where alarms also might trigger, but even in that case there are deferred up to 9 minutes. And then if you look at the app standby buckets, in addition to those, they will apply restrictions. For example, if you end up in that working set bucket, so not active, not super actively used, but used once in a while, then you see that your jobs might be deferred up to 2 hours already, and your alarms also might be deferred. And if you end up in that rare bucket, then things get worse. It might be deferred up to 24 hours, which probably mostly translates to any jobs that you have scheduled will at least run once a day. And the same for alarms and network as well. So you can't really rely on network being present at any time, even if you try to use an alarm here, which is less deferred. There's no guarantee that the network will actually work. And you see that even cloud messaging is also restricted. So you can't cheat your way out of this here. You can't say, well, let's send a lot of high priority notifications to my device and make sure that the app wakes up. It just doesn't work that way. This all makes sense from a user perspective. If the app is not used that much, it shouldn't use that much battery either, right? And in combination with that WorkManager feature where the jobs will just be ran within your app, it will usually be just fine if the user comes back to your app catches up and everything resumes as normal. Okay, so let's talk a little bit about debugging all of this. Because all the combination of non-exact jobs and app standby those will affect how you debug this. Because if you are just opening your app, then you will definitely have your app in the active bucket all the time. So there will be less restrictions on it compared to a normal user that is installing your app and has multiple apps. It's not just your app that they are using. You can inspect from ADB what the standby bucket is after a while. And you can also force a particular bucket. The weird thing is that when you expect it, it will give you the name. If you want to set the bucket, then you have to set a number. You can also do this in developer settings. So you can inspect from every app what the standby bucket is. And this will give you a clue on why maybe some things are not working as you expect. What's a really useful option here to me is the option to make the device think that it's not plugged into any power source. Because if you plug in your device to a power source, for example, to debug it or to look at the logcat, then the dose restrictions will be gone, and other battery restrictions will also be relaxed a little bit. So you can use ADB dumsys battery unplugged to make it think it's not unplugged while it actually is. And that, in combination with having a log file in your app that logs out some information on the tasks that are being performed. If you do that, then you don't have to open your app, and you can look at logcat and other things you might want to do over ADB to inspect how your app is doing. And then if you want to test those, for example, if you want to check if some jobs run while dozing, or if alarms trigger or that kind of stuff, then you can force it into doze mode as well. And you can also unforce it, of course, which is nice, because now you can see how it transitions when the device comes out of doze. What you often will see is, well, maybe you have noticed this, if you have that nightstand example where your app is on the nightstand, at some point you turn on your screen and boop, there will be notifications coming in. That's because during doze, these things have been deferred. And so using these ADB commands, you can emulate that. And then you might want to debug WorkManager as well. You might want to verify that the tasks that you have scheduled are actually scheduled. And for that, in the latest stable WorkManager release, there is a broadcast that you can send to it with this command. And depending on whether you care or not, this is not restricted to debug builds. So you might want to turn this off for release builds. If you want to do that thing, you can just use the manifest manager to remove that broadcast receiver from your app. But it's a very useful tool to see if what you think is happening is actually happening on the WorkManager side. And then for job scheduler, this command has been my life for in the past weeks. There's a lot of info collected by job scheduler, and you can get that info by running ADB shell dumsys job scheduler. And I would recommend it to dump this to a file, because on my device it gives me a 5,000 line file or something like that. So it's a lot of scrolling up if you don't dump it to a file. But that has basically all the state that job scheduler knows about your jobs. And it gets a little bit intimidating when you see that for the first time, but what I would like to do is run through it a little bit and show you what the useful bits of that are. And that means I have to switch my screen, and I hope that works. So let's see. Switch. I think that works. Let me. Does that work, Rob?
Yes, it does. Loud and clear.
Okay, great. Okay, great. Yeah, I wasn't seeing Rob now. Switching my screen and seeing Rob. How nice. So yeah, let's first look at this. This is the output of that WorkManager dump. I hope it's visible. It's not the greatest formatting. Maybe I can. Well, it doesn't get any bigger than this. But it lists out some interesting things. At first, you see an idea, and you see the worker that's being run. And if you look at the name of that worker, you see that while you're running this diagnostics, it's actually running that in a worker, which is kind of interesting. And then these are the ones that are scheduled from our app. So if you see again, you see an idea, you see the name of the worker, and you see its state. So the diagnostic thing is obviously running because it's outputting some data. The other ones are enqueued, so they're waiting to be executed at some point in time. And you see that these workers also have a unique name. So in WorkManager, you can give jobs unique names, which is convenient if you want to ensure only one instance of this thing is running. or is being queued, and so you can replace them or update them or skip them if they're already unqueued. So this is what we use in our app. So from this output, you can already basically see what should be scheduled on Job Scheduler. And then the adventure to the dump sys of Job Scheduler begins. This is this file. Not sure if you get the scrolling, but it's a lot of info. I will point out, I think, the useful bits of this. I hope that still works, but we'll see. So at the top, which is interesting, which I actually noticed yesterday, there's a heartbeat. And in that heartbeat, you can see there's a number. And then there are these buckets, the standby buckets. So you see that basically the heartbeat is at 850. And the active bucket is at 0, which means that at every heartbeat there, your active app buckets will be considered. But you also see that if it's in the working set, it's already being throttled. It will skip a couple of heartbeats to consider those jobs. So I think that's just informational. It's like looking under the hood of Job Scheduler, but yeah, that's what I noticed. If you scroll through this file, you see a lot of this. So these are basically all the jobs that have been scheduled by any app on your device. And what you would want to do is basically search for your package name, and then a slash, and then Android X. This will always be the service that WorkManager is using under the hood to schedule your job on Job Scheduler. So if you want to find your jobs, I usually do something like, I probably have it here somewhere. I usually do something like this. I say, oh yeah, here are my jobs, and then I can basically find them in this file. And then for every file you see, this is your application UID and the job number. And this number comes back in different places. But so it's good to know that it's there. And then you see some extras that are being sent from Job Scheduler. Again, this is interesting because this is the unique ID that's also in the WorkManager dump. So if you want to validate that this job that you're expecting to be there is actually there, you can also search for that UID. And Job Scheduler adds some extra data to indicate that this is a periodic job. You see that this job requires a network. And you can also see it has a delay of at least about 4 hours. And then you can see some other interesting things that are the constraints. So it has a timing delay. Well, it's basically the same thing as this. And it needs connectivity. Same thing as what's specified here. And then you can see what constraints are satisfied. So the timing delay has been satisfied. Some implied things like the device is not dozing and it's not background restricted by the user. So in addition to to battery savings, a user can tell the system not to run any background for any app. If a user does that, that's pretty bad for you as a developer. But yeah, you will notice this in the logs if you find this. And then in this case, we also see an unsatisfied constraint, which is connectivity. So that means that this device was probably not connected and waiting for executing this job. Then super useful here is that the standby bucket for this app is rare. So you know that you're already restricted here. And you see when it was enqueued. So it was enqueued about 10 hours ago. And it was expected to run, like about 6 hours ago, which makes sense because we had a delay of 4 hours. And yeah, it didn't run, right? It is 5 hours overdue already. And that's due to the connectivity constraint in this case. So this little tidbit gives a lot of info on, I'm expecting some job to run. It didn't run. Why didn't it run? Is it delayed? Is it when does the system plan to run it? So this is super useful if you're having these questions. And the other jobs have the same kind of information here. If you scroll further down, there's a lot of stuff in here, but if you go further down, what's particularly interesting is this job history, which basically will list you all the the history, literally the history of the jobs that have been run. In this case, about the past hour. I'm not sure if that's so. There are quite a bit of jobs. You see that a lot of. Let's see where my jobs are. And this is super useful to understand. For example, if you're looking at your device and you think, well, it should trigger any moment now, and then you look again, you pull this dump sys again, and you see, well, the next run is in 5 hours. What happened? Then it probably has run, and then looking at this thing, this list can help because it will just tell you, I ran this job like 5 seconds ago. It's also very helpful to find out if your job doesn't run. I have an example here. Let's go here. So in this case, I only see one of my 3 jobs here, which is bad, which is not what I expect. So WorkManager would still tell me I have three jobs scheduled. If I look at job scheduler, only one. We know something is going on. What exactly? If you dive into here, it's not. Yeah, the formatting is not super great, but you can see 41 seconds ago, tried to run this job. It has a number. It's the same number as you would see in the previous dump. And then it says timed out while binding. And in this case, it's super bad because timed out while binding means basically I couldn't start a process. In this case, I know this happens because on some devices there are some excessive battery savings going on. But to make this worse, that there's also a bug in Job Scheduler which then basically removes your job from the queue. So it will never run again. And to pile on to those problems, if you then open the app, your jobs will get run by WorkManager again because they are still scheduled, but they will never be added to Job Scheduler anymore. This is a bug that we had identified and we filed, and is now also fixed in the latest alpha release of WorkManager. So I think this is pretty particular to our app because we want to have these jobs being put back on Job Scheduler for sure, because the chances that you open an app, a COVID notification app, that many times is pretty low. For more normal apps, WorkManager would have your back, I guess, using that in-process scheduler. But still, that they fixed it is pretty nice. And the last thing that I wanted to point out, that it has this ready to rock is true, which is cool. And yeah, always ready to rock. Other than that, it's not really, But there's a lot more stuff in this, but I think those two I wanted to highlight. And I think that's all I had. Let me see. Yeah, that's all I had. I want to take you on my travels to DumpSys Job Scheduler.
All right. Cool stuff. Really nice to get this in-depth view of all the dump logs and what it means. I would have never figured that out by myself. Great to see.
It took me a while.
Yeah, it was a great primer.
Yeah.
All right. Oh, thank you for your talk. Let's see if there's any questions, actually. I saw Dion made a request in the chat, but nothing has come in yet. But there's always a couple of seconds delay, so let's see if anything flows in the meantime. It's also really nice to see that with the WorkManager, it's so easy to schedule like a foreground service. I know I've struggled with that quite a bit, and sometimes it works, and then sometimes it was just complaining. I don't remember exactly what the error was, but I guess the notification wasn't spawned yet or something, or I called start foreground and then complained that it was already in the foreground. Nice to see that that's just one line of code here and you're good to go.
Yeah, you basically have to create a notification and then tell WorkManager to show it, and then it just works. And it's the same API, so if you change your mind later, that doesn't need to be a foreground service or it doesn't need to run longer than 10 minutes. then you could just remove that line of code and it just works again. So that's great.
Yeah, that sounds super convenient. In the meantime, some questions are popping up. So let's see. Shervin is asking, would wireless ADB connection make debugging this easier? So I guess it's referring to what you mentioned, where you can fake it being connected or charging.
Yeah, I didn't try, but I would expect that if your device is dozing, that the connection to your wireless ADB is also gone. So that's probably an issue there. Because especially in those, it will just turn off the radios. Maybe there's an exception for wireless ADB, but then again, you might also disturb the debugging in that way. So it's kind of tricky. Yeah, it's kind of also the other way around is also true, right? If you have a device which runs some jobs and you just leave it on your desk and don't interact with it, that's also not a very realistic scenario. So you have to make sure that you turn it off once and turn it on once in a while to emulate what a user would do, unless you literally want to have the worst case scenario. So it's kind of tricky to have a more realistic scenario, because we also tried, for example, to increase the frequency of our jobs, but then you might run into the throttling, or you might keep your app processor alive, which is also kind of not realistic. So it's a very thin line when you are trying to figure out specific issues, at least.
Yeah, it sounds really finicky to really emulate the real world there.
Yeah, but the battery unplug is great for that, because you can just leave it on your desk and plug it in once in a while to check in on it.
Yeah, cool. All right, clear. Maarten is asking, or he says, thank you for the great debug stuff. You mentioned it fails if the work takes too long. How long is too long?
I think it's 10 minutes for job scheduler. I'm not sure if that's set in stone, and you probably don't want to push that 10 minutes, but it's 10 minutes. I don't think it's documented to be 10 minutes, so it's probably subject to change. But
it's good to have a ballpark figure like that.
Yeah, 10 minutes is a good ballpark figure, and it's not something that I think they will change soon. But if you're going in that direction, like 10 minutes, then you should really consider doing that foreground service. And you would notice that because your job will just get canceled.
But 10 minutes already sounds super long to me, to be honest. But
yes, and also keep in mind that it's, for example, if you're in that rare bucket, there's a limit. I think it gives you 10 minutes a day max. So if you have, if you have a couple of short jobs, then you have more chance to run it. Otherwise, you will just run out of your quota.
Yeah. All right. Marta says thanks. Then let's see, what else do we have? Ilya is asking, can you use WorkManager to perform a long-running tasks? For example, need to download a large firmware file, all or nothing, undetermined duration. Last I read the docs, I understood there was a time limitation.
So if you use that foreground service, then that's designed for that. So if you know that's going to take a long time, then a foreground service is not limited in that sense. It has higher priority. Of course, it might get killed by the system if you make that like really long. But it's meant to be kept alive as long as possible. And it's also that foreground situation is really designed for long downloads of that kind of stuff. So yeah, I would definitely then switch to the foreground service, because then it's no longer a job, right? It's being triggered as a job, but it will then live on as a foreground service that is managed by WorkManager itself, and no longer by the job scheduler, for example.
So. Yeah. All right. I think that answers the question. Cool. That seems to be it for now. If there's anything else, I'll keep an eye on it for a bit. Yeah, no, with that, I just want to thank you for the great talk, and thank you for joining us again. And well, I hope to see you in real life again at the meetup soon, but we'll have to
Yes,
be a bit
hopefully.
patient for that for now. For now, thanks so much for joining us online.
Yes, great to be here. Thank you.
All right, thanks everyone. See you next time.
Bye.